In this lecture video, we're going to discuss about the interrupt of 8086. So previously we have discussed about the architecture of 8086. So major features of architecture is we have a pipelining technique where up to 6 byte instructions, that is 6 instructions, can be stored and it can be prefetched, and without any delay we can be executing the next instructions in which are in the queue. So pipelining and queue, we have a unique feature in 8086. Apart from that, this is the first 16-bit microprocessors where the registers are also 16-bit registers, like code segment, stack segment, or for all the registers we have up to 16-bit registers. And coming to the interrupt part, in interrupt here we have mainly two interrupts, that is hardware interrupt and software interrupt. And these hardware interrupt and software interrupt are further classified. Like you can see, in hardware interrupt we have maskable and non-maskable interrupt. So what is mainly the interrupt is, as we discussed earlier in 8085, it is a method of creating a temporary halt during program execution and allows the peripheral device to access the microprocessor. So the microprocessor responds to the interrupt with the ISR. So ISR is nothing but interrupt service routine, which is the short program to instruct the microprocessor on how to handle the interrupt. So what is this hardware interrupt? So interrupt we know now. So let us discuss what is this hardware interrupt. Hardware interrupt is caused by any peripheral device by sending a signal through the specified pin to the microprocessor. So note that point, it is sent via the pin of the microprocessor. So we have two types of hardware interrupts, that is non-maskable interrupt and maskable interrupt. So non-maskable interrupt and interrupt is a mask have the lower priority and higher priority. One more interrupt is associated with is INTA, that is interrupt acknowledgement. So non-maskable interrupt, what is that? It is a single having highest priority than the maskable interrupt, and it is of type 2, which is the interrupt when this interrupt is activated is completes the current instruction that is in progress, pushes the flag register values onto the stack, pushes the code segment value and IP value of the return address on the stack, and IP is loaded from the contents of word location, and CS is loaded from the context of next word location. Interrupt flag and trap flag are reset to 0. So when we can discuss when this interrupt, that is maskable interrupt, happens is it will be interrupt only if interrupts are enabled during the set interrupt flag instruction. It should not be enabled using clear interrupt flag instruction. So these actions are taken by the microprocessor, like first completes the current instruction, activates the INTA output and receives the interrupt type and say X. Flag register values CS value of the return address and IP value of the return address are pushed on the stack. IP value is loaded from the context of the word location X into 4, and CS is loaded from the contents of the next word location. Interrupt flag and trap flag is reset to 0. So coming to the software interrupts. What are the software interrupts is, some instructions are inserted at the desired position into the program to create an instruction. So hardware interrupts is whenever we need an external interrupt, like we have a main program and we have to immediately execute some subprograms on the spot, we use an hardware interrupts. But in default I have to give the interrupt at periodic intervals, so I am using the software interrupt. These interrupts instructions can be used to test the working of various interrupt handlers. And INT interrupt instruction with the type number, it is a 2 byte instruction. First byte provides the opcode and second byte provides the interrupt type number. There are 256 interrupt types under this group. Its execution includes the following step. As usual, flag register value should be pushed on the top, CS value of the return address and IP value of the return address are pushed on the stack. IP value is loaded from the context of the word location type number into 4. CS is loaded from the context of the next word location. Interrupt flag and trap flag are reset to 0. So apart from this, we have interrupt 3, that is 3 three breakpoint interruption instruction, and interrupt on overflow instruction, and many other. But most probably we will be using INTR and INTA and RST, like that we'll be using on. And most probably the trap is the most important in 8085 also and 86 also, because it has the highest priority. In the next lecture we will be discussing about the for instruction format and instruction set for the 8086. Thank you.